Okay, my fellow listeners and learners of chemistry all over the world, this is just a short video describing and explaining the ideal gas equation, how it is being derived. Okay, the derivation of ideal gas equation. It was actually coined from three of the gas laws, which are the Boyle's law and the Charles law and the Avogadro's law. Okay, very quickly, the Boyle's law is inversely proportional to P. Okay, meanwhile, the Charles law, the volume is directly proportional to T. Okay, and here the volume is directly proportional to the number of molecules. So if you combine these three together, what will come out? That means the volume of a gas, or if a fixed mass of a gas is proportional, are you seeing it? To the inverse of pressure, okay, times directly proportional to temperature, as in this case, times directly proportional to the number of molecules in here. Okay, that means this one will lead you to V is proportional to this times this will give you NT over P. Okay, so if you introduce sign of proportionality, the constant, you are going to be having V is equal to RNT over P, where R is our constant called the molar gas constant. So by indication, if you are going to have PV is equal to NRT. Okay, this is our ideal gas equation. Do you understand? That is how we derive the ideal gas equation. Remember, P is the pressure. It has different unit, Pascal, bar, Newton per meter square, and etc. Okay, torr and the rest of them. Volume, liter in liter, volume in centimeter cube, volume in meter cube, and etc. Number of moles is number of moles. R is the molar gas content, and T is the temperature. Okay, in Kelvin, if it's given to you in degree C, you convert to Kelvin. Okay, ensure that all the units are in the same, unit, depending on the value of R. So R can actually be derived, which is the molar gas constant. Just look at what I'm going to do now. So from the formula we just got, that where we said PV PV is equal to NRT. So if you make R the subject of the formula, you are going to have R is equal to PV over NT. Okay, so pressure, let's use pressure of 1 atmosphere, volume of 22.4 liter. Okay, N is the number of mole, which is, let's use 1 as the number of mole, and T as 273 Kelvin. And let's see what R will give to us. R will simply give to us, R is equal to pressure. We have 1 atmosphere, okay, times volume, which is 22.4 liter. We have 22.4 liter, or 22.4 dm cube, or 22400 centimeter cube. Okay, depending on the units you are having here, will give you different values of R. Okay, 22.4 liter divided by what? N, the number of mole as 1 mole of a gas. Okay, at and at STP times the temperature at 273 Kelvin. So you will be, if you divide this, you will be having a value you will be having a value of, if you divide it well, a value of 0.0821, okay, which is in liter. Let me write it here. 0.0821, okay, which will be in liter. You can create your unit here, or atmosphere liter atmosphere, okay, then per mole, per mole, per mole, per mole, then per Kelvin. Liter atmosphere per mole per Kelvin, per Kelvin, per mole per Kelvin. Or you say atmosphere, since A comes before L, atmosphere liter, so per mole per Kelvin, atmosphere liter per mole per Kelvin, per mole per Kelvin. Do you understand that? So this is a constant value of the molar gas constant when your pressure is in atmosphere. Okay, when your pressure is in atmosphere, you can get that value of. So if we will obtain another constant value for R, in that case, we are making our pressure, we are using pressure which is equal to 1.01325 times 10 raised to power 5 Pascal, okay, or times 10 raised to power 5 Newton per meter square. Okay, if you use that value, okay, remove it from standard form, you will be having 101,325, okay, times remember it is in Newton per meter square, so this volume will now be in meter cube. Okay, converting this 22.4 liter to meter cube, you will be having 0.024, okay, divided by, then the number of mole remain 1 times our temperature remain 273. If you solve this, you are going to have 8.314. It will be in joule, okay, joule per Kelvin per mole, okay, or joule, okay, per Kelvin, then per mole. Okay, I hope you understand. With this, you don't need to come. You can actually derive your molar gas constant. So it's not something you should be coming. With this, I believe you understand, okay, what the ideal gas equation is all about now. Okay, beyond this, there are other formulas you can derive from this PV is equal to nRT. Okay, I will be intimating you with the formula now, that apart from the question where the number of moles, you'll be giving mass, okay, of the gas, but you will not be given the number of moles. What do you do in that situation? Sometimes they will ask you to calculate for the density of the gas, and here you have volume, so you can calculate density from here. Sometimes you'll be asked to calculate the force exerted by the gas, okay, and you know that pressure is equal to force over area, okay. Let me bring out some derivation, okay, that we can get from the PV is equal to nRT. And most of these questions comes up, most of these questions, usually come up in the examination, and students are confused on where is the formula to, because these formulas are not found in textbooks. They do not know that they need to use you need to think to derive a new formula from an existing formula. Okay, just look at what I want to do now. So look at this, that we have PV is equal to nRT, which is our ideal gas constant. So where you have N, which is number of moles, okay, is equal to mass in gram over the molar mass. You see, this is small letter m, this is capital letter M. The capital letter M is the molecular weight of the gas, while the small letter m is the mass of the grams. Okay, I don't want to be writing in words. So as you hear me, if you are learning, you can write it down, you pause the video, you write, and you have a better understanding. Okay, now if you bring, if this is equation 1 and this is equation 2, just simply substitute equation 2 into equation 1. That means you are going to be having PV is equal to, what is N? Mass in gram over molar mass. Okay, you put it here, then you have RT. This RT will continue. Okay, this is another formula. That means you are going to be having PV is equal to what? Small letter m RT over m. Okay, this is another formula. Okay, in case you are asked to look for either the mass of the gas or the molecular weight of the gas, there are even questions where they will now ask you to assume what is the name of the gas. From its molecular weight, you can assume that. Okay, so anything you are looking for here, this equation can go. Another one is, if please just watch. If 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 density, you have density equals to mass over volume. Okay, and here you have volume, and we want to make volume the subject of the formula. Our volume will become what now? Mass over density. Do you understand? So you can use anything to represent density, maybe rho in Greek word like this. Okay, but I want to use this for easy comprehension of this thing for those who are learning. Okay, so if I say this is my equation 3, if this is my equation 3, I want to put this equation 3 in equation 1. So it means I'm going to have in my equation 1, which is pressure times, what is volume? Volume is what? Mass over density. Mass over density, okay, is equal to what now? nRT. This is another formula. You can see now that you have PM over D is equal to nRT. This is another formula that you can generate. You don't need to cram this, please. You can generate this formula. Another one is, you can see that we got a number of mole to be mass in gram over molar mass, and our V to be what? M over D. I can put equation 2 inside equation 1 and equation 3 inside equation 1 simultaneously. So what I'm saying now is that substitute equation 2, substitute equation 2, substitute equation 2, 2 and 3 into 1. Okay, I hope you understand. What is equation 2? Equation 2 is this, mass in gram over molar mass, put it here. And equation 3 is what? V equal to M over D, put it here. So if you put equation 3, you have P times, what is equation 3? What is V? V will be M over D is equal to, are you seeing now? What is N here? N is what? Mass in gram over molar mass, okay, times RT. RT. You can see M will cancel M. In this case, you are left with P over D. P over D is equal to what? RT over. So you can see RT over M. Okay. So here now you may be required to calculate density. You may be required to calculate the molecular mass. Okay. So this is another formula. You may be required to calculate any parameter here. Okay. You see, this is one formula. This is another formula. This is another formula. You can generate another formula. Okay, from this ideal gas equation. Remember here, number of mole equal to mass in gram over molar mass. Okay, there are other formula for number of moles, okay, that you can put here. It's not just mass in gram over molar mass. Okay, yeah, pressure is equal to force over area. You can derive that and also put it there. Okay, look at this. So where pressure is equal to the force applied over the area, that means if you substitute this into this, okay, let's call this equation 4. Let's call this equation 3. If you substitute this into this, 4 into 3, you are going to have, what is pressure? Force over area times volume is equal to nRT. And you know, area is what? Area is length times breadth times height. Volume is what? Area is length times breadth. Volume is what? Length times breadth times height. That means you can cancel area from volume, so that you are going to have F times, okay, length, okay, is equal to nRT. So you can actually have FL or FD, okay, the distance, okay, is equal to nRT. This is also another formula that can be generated. I hope you understand. Okay, then we also have another one from the number of moles. Okay, and what is it? You know, we have number of moles is equal to concentration times volume. Okay, you can also put this inside here, and you are going to have a new formula. I hope you understand, which is CV. If you put CV here, you have a new formula. In that case, V we nullify V, so that you are going to have P is equal to C RT. Okay, you generate new formula for yourself. So in your comment section, I want you to generate on your own and put it there. Okay, and I will score you from there. I hope you do understand. There are also other formula for number of moles that relate to particles. You can also include them there. Though this formula relating to number of moles relates to solution in chemistry, but this is an ideal gas. Sometimes questions are asked where they will want to confuse students, on question that is supposed to be from ideal gas. They are relating it to solutions, molecules in solution. But you have to understand that this is an examination. You need to create a formula from, an existing formula where you can use to apply that formula in your question, so that you obtain the right answer in the examination condition. Hello, fellow learners and my students in chemistry. I want to appreciate you for always watching this video. I want you to just please like and also make your comment if you like the video. Okay, and also send and share to others, so that they can subscribe into this channel. Please encourage people to subscribe, and you that you are watching now, please, I encourage you, please kindly subscribe to this channel, and you will always be notified whenever I upload a new video. Thank you.